this video, I'll be demonstrating the dependent t-test in SPSS. And to start off, just a reminder that we have our data window over here on the left, our output window over here on the right, and we're using our sample data here. So we have these different variables. We have age, a couple of categorical variables here, point of view and sentence type. We have timing and rating 1 and rating 2. And for our purposes here today, we're going to assume that rating 1 and rating 2 are before and after our experimental manipulation. Since we're focusing on the dependent t-test, these are the variables that we'll be focusing on today. And so typically, the first thing that I want to do whenever I'm doing any kind of analysis is really going to be to get some descriptive statistics first. So I'm going to get descriptive statistics for rating 1 and rating 2 here. So I can go to Analyze, Descriptive Statistics, and Descriptives. It's just a little bit of review here. And I'm going to select rating 1 and rating 2 and say OK. So I have those ratings here now. I have their means, their standard deviations. And now to do my dependent t-test, I'm going to go to Analyze. I'm going to come down here to Compare Means. And I'm going to select Paired Samples t-test. And if you remember, this is one of those names that the dependent t-test goes by, including things like matched pairs, t-test for dependent means, and these other names that we've discussed. So I'm going to select Paired Samples t-test here. And here what I'm going to do is I'm going to take rating 2, our after variable. I'm going to put in the variable 1 slot, and rating 1, our before variable, in the variable 2 slot. And basically arranging it this way is going to give us, just like we did by hand, that after minus before calculation for our different scores. I'm going to click OK. Let me go ahead and make this a little bit bigger. And so what we can see here is that we actually do get these means and standard deviations actually automatically. So I actually did not have to do this up here. And for our paired samples test, we also get the mean and standard deviation of the rating scores. And we can see this is rating 2 minus rating 1, and the mean and standard deviation of that. And so this is going to be kind of the average difference, essentially, which we can see if we look at the difference between our two means for rating 2 and rating 1, those two variables. We can see that we have our t-score here, degrees of freedom, and also our significance level, or our p-value in this case. And so we have all of this information, and we really have everything we need at this point to write our results. And so I'm just going to add in some text here so I can go ahead and write some results for us. And so I'm going to start off by using some descriptive statistics. So that rating 1 was 3.58. Typically in AP format, we're rounding out to 2 decimal places rather. I'm going to say SB equals 1.24. That's our standard deviation, which we see right up here. Again, rounding to 2 decimal places. And for rating 2 was 2.442. Once we round that, 416 rounds to 0.42. And SD equals 0.90. Those are our descriptive statistics here. Getting into our inferential statistics, I can say experimental manipulation. In a decrease, we can see that rating 2 is lower than rating 1. We have this negative t-score here, so we have a decrease here. We have those descriptive statistics now for those different scores to show how much of that decrease that we saw on average. A decrease of negative 1.17. SD equals 1.7. And rating And so our terms manipulation resulted in a decrease, mean of negative 1.17, standard deviation of 1.27, and rating. I've really only given descriptive stats here still, so I need to make sure to give our statistical language for the dependent t-test. And so I can go on here and say, deduction is significant T to show that I did a t-test, and my degrees of freedom here equals, and put in my t-score, negative 3.19 when we round it, P equals 0.009. The p-value here, again, we typically in AP style prefer to have the equal sign. Because we have 3 decimal places, I could round this to 0.01. I could say it's less than 0.01 in this case, and so all of that is just fine. And so this now would be a nice report of my statistical language here, a nice report of my results, giving both descriptive statistics and those inferential statistics, and also showing what that relationship is and what that effect looks like in words.